Today I'll be showing you guys how to create these stairs that automatically size themselves to any size of cutout that you would like. So if I make it super wide, it'll automatically become super wide. If I make it really narrow, it'll automatically become super narrow. So it doesn't matter what size I have it, and it copies them all the way down through the floors as much as you want. If you want to no longer go down lower, it will not go any lower. And you can use the same system to create elevator shafts, as you can see, that go as far down as you would like, and it automatically scales it and fits it in accordingly. Now, before we get started, there's one small tweak that we need to do for the interiors from last week that you guys have pointed out to me. And that is these exterior walls that we're actually getting from our wall section and we're cutting out from our interior walls. The problem with this is this doesn't include the doors because we're actually removing the doors here. These doors are here and they're not included. So specifically on the first floor, these doors might be missed. And in which case you'll get a interior wall effectively being on the exterior, which is what you don't want. So what we can do is basically merge these doors with these walls. So what I'm going to do is just drag out of the static mesh spawner here, search for named reroute declaration node, press F2 to rename it, and we'll rename it to exterior doors. And all I'm going to do is just get the exterior doors here and plug them into this merge points node. It basically gets all merged together into the original walls. So now we're getting both of the walls and the doors. If I sample this, you can see we're getting both the doors and the walls. Everything is highlighted here. And that's all that's needed for the fix. And if you find any other fixes, please let me know so I can go ahead and address them in the following tutorials. But now let's get into actually creating both an elevator shaft and stairs, or kind of a method to do both. Now, there's going to be a slight difference between the two, and it's pretty much a single on-off switch between the two, which is effectively to have one of them is going to have to need to go up an extra level, and one of them doesn't. What I mean is when you have an elevator, and let's say you're on the top floor, you want the elevator on that floor. But if you have a staircase, you don't want stairs on that top floor because then now it's going to this roof. You don't want that last little bit of stairs. So we're going to make sure that we have an option to turn one versus another, and I'll show you how to get those all in. And the other thing we're going to do is make sure that you can have it as any scale and any size you'd like. It is not going to be bound per module. It is going to be module based still because it's going to need to make the holes for it, but you can have it really long, get really wide, any kind of shape you want. So let's go ahead and get started on this. First thing I'm going to do is grab one of these trigger boxes, or you can go up here and search trigger box and grab one of those. Either one will work. And what I'm going to do is just position it kind of up here near the top. Let's say right here for testing in our upper floor. And then in the detail panel, let's search for tag and let's give it a tag. I'll give it the tag stairs. Now, this will also work for elevator, but if you would like to, you could have a separate system to have both stairs and elevators. I'm going to be showing you right now how to kind of swap between the two. But in the future tutorial, we might create two separate systems so that way we can have both stairs and elevators. But it should be as simple as just duplicating it if you want to do it for yourself, and then just changing one of the tags. So using the stuff that I showed today, you should be able to just duplicate it and actually get it all working for yourself as well if you want to. But now that we have the stairs tag and this shape, we now need to remove the actual walls and floors. Now we need to remove the interior wall specifically, and then we need to remove the floor and the ceiling. And we want to remove those separately. We don't want it to go in one go. This way, when you're creating, let's say, an elevator, maybe you don't want the floor in because you have your own custom floor, but you might want the ceiling in from the floor below it, and vice versa, depending how you're doing it. We'll start over here on our interior walls and doors, and we'll do that pretty much near the end, right before this open close back walls, just basically before the static mesh spawner. I'll take this, scooch it over, and now I want to grab ourselves a difference node. We'll set that to binary right away. And now I can right click and search for get actor data. Instead of self, it's going to be all world actors by tag, and we're going to call it stairs. We want to make sure select multiple is checked on, and we want to get a single point and turn off track actors only within bounds. If you don't do that, basically when you have things far away from that original spline, it just will ignore it. So you kind of want to track all of them. So all we need to do is take this get actor data, plug it into the differences node. The original transform points goes into our source, and then we just plug this difference node all the way through into our open back walls. And that's kind of all we need here, but we're going to need this in other places as well. So I'm going to take this, I'm going to copy it. We're going to go here to our floor/ceiling area. So I'll go ahead and just kind of make this a little bit bigger of an area. I'll take all of this and just scooch it to the side. And basically right before the static mesh spawner, I'll paste in this as well. So I'll plug in our offset transform into the source and this into the static mesh spawner. And I want the same thing up above. So I'll plug the top one into the source, that into the static mesh spawner, and we can just plug in the same get actor data into both here. Now, the reason I'm doing it here and not earlier is because this is where after we've separated it. And like I said, I want to make it so I can choose to have the floor cut out or the ceiling cut out or both. I don't need to have just one. So now if we take a look, you can see it is now cutting it out, which is great. And if I raise this up higher, I end up here. You could see it has removed the floor of this next floor, but from below, I still have the perfect ceiling. And if I go down lower, I still have the floor here, but from below, I have no ceiling. And you can see it is cutting out into the lower floor. And this is an area where we don't have actual interiors. So let's go ahead and move it just up here so I can show you that is also cutting out the interiors just like so, which is perfect. So the simple part is done. We have now things cutting out. Now we want to go ahead and take the information of the size and everything that we have cut out and place something in there. Now, what we're going to be doing is basically taking our elevator shaft or our stairs or whatever it is, and we want to scale it to the actual shape. To do that, let's go ahead and add an extra entry in our data assets to get that information. Here's our PDA modular building here. And I'm going to go ahead and duplicate one of these arrays, and we'll just rename this to stairs. We'll put elevator here as well, and I'll show you that we can just swap between them and modify them as needed. In our data asset, we can go ahead and add a new input for our stairs. And I'll begin with actually using an elevator. I create this very basic module of just corners, basically to create an elevator shaft to just show how it all scales. Most likely, if you're doing like a full-on elevator, you'll want to do it with blueprints or another way. But this is to show you how you can quickly put in a mesh and have it copied up as your base to fit your needs. So now we want to find the original points that it's intersecting in the floor. We have that here in our floor/ceiling section. We have the points that we're copying up. And if I go ahead and sample them, you can see here all our points right here in the interior. And this is all we need, but we need to know which ones are being overlapped here specifically. To do that, we're going to need a named reroute because we're going to need this point information. So I'll search for named reroute declaration node. I'll press F2 and I'll just rename this floors and ceilings. And to make it cleaner, I'll just pipe this all the way through like so. And now we have this floors and ceilings section that we can just grab wherever we need. I'll go ahead and get started with it in this empty area here. So something we're going to need is to get our floors and ceilings. We're also going to need to get the actual data that we have from our little section here. So I'm going to go ahead and grab ourselves this get actor data with all our stuff already configured. And I'm going to duplicate it up here. Now, effectively what we need to do is take a look at everything that's overlapping, all of the points, merge them together and see the size of that merge, and also account for the fact that the wall size is going to be a little bit bigger than their current bounds. So we need to make sure that everything fits accordingly. And basically, we're going to be scaling it to all be correct. It might be a little bit confusing right now, but don't worry, I'll guide you through it step by step as we're creating this. And to do that, we're going to be creating a loop to go through all of the points that we have overlapped. Here in our loop folder, I'm going to right click, search PCG, grab ourselves a new PCG graph, and this is going to be our PCG get selection bounds. Then I'm going to take it, drag it in, and create a loop node. And then I can double click it to open it up. So inside this loop, you want to recreate this setup. In the output here, we have just a normal point, pin status required. And for their input, we have a regular floor point set to point. All of these are set to required. The second input is just a loop point, also required. And the rest are all attribute sets, as you see right here, all set to required and all being normal. Now to immediately be able to sample what's going on here, let's go ahead and plug this into our section here. So our floors and ceilings are going to go into our floor points. Our get actor data stairs go to a differences node. Then we need the wall size, the wall height, as well as the data assets. So I'll grab wall size, wall height. I'll grab it all from over here, duplicate it over. Wall size go into wall size, wall height into wall height, data asset into our data asset input. And stairs mode is going to be a bool. Now, this is basically to swap between, again, having that extra level versus not having extra level between elevators and stairs. Now, in order not to hard code this, I'm going to create a new variable on the blueprint that we can control this with. So open up your original blueprint. that houses your spline and your PCG graph. And let's make a new actual variable here. For this, we're just call this stairs mode. It is going to be a type bool, and it'll be off by default. But we want to make sure that it is exposed, so turn the eye icon on the right on. So now we can go ahead and grab ourselves a new get actor property. And in the right, under property name, we want to type in the same name we just called it. So stairs mode, and then plug that into our stairs mode. So right now, this doesn't really do anything. It doesn't output anything, but that's okay. Let's go ahead and open our loop now. And let's get started here. The first thing we need to know is which points are the ones that are overlapping with our selection. To do that, we're grabbing our floor points and doing an intersection. And we're doing it with the difference here. Now, the reason the difference is the actual loop is because we are selecting multiple selections. And each selection we want to do this on. We don't want to do it on all of them together. We want to have every single one of these elevators or stairs be addressed separately. As soon as we have this, I can actually select it, press D to debug it, and you can already see that we're getting the points that we're overlapping. We can grab 4, we can grab 2, we can grab any amount of them depending on what we're overlapping. So already we have a good start. But once it has done this, if I press A and open up our building 2, which is where I'm currently actually testing this, you can see each one of these points is separated out, and we don't really want this to be separated out. So from here, I'm going to just merge the points all together by using a merge points. And basically all of those points that are intersecting are now one single group of points. If I press A, we can see here are the 4 points, and we only have them here. Excellent. From here, we can use a new node, which is called combine points. And what this does is if I debug this, you can see those 4 points have been merged into, well, one larger one. If I move this a little over, you can see now only these 2 are merged. So now we're actually getting kind of the bounds of the shape. Now, the problem is with this, right, is ours is a little bit bigger than this point information. So we need to account for that. And what I want to do is make this point the full size of this hole exactly. By making it exactly the size of the hole, we can now scale the actual mesh, whatever we put into it, to be exactly the size of the bounds of that point, making it a lot easier for us. So from this combined points, I'm going to grab ourselves a get attribute from point index, and we're going to grab 2 of them. And what we want to do is in the top one, I'll press the plus button here in the detail panel and grab our bounds max, and in the bottom one I'll grab our bounds min, because we need to modify the bounds of this. So out of this combined points, I'll drag out and search for bounds modifier. I'll open it up because we're going to need access to bounds min and bounds max, and we're also, instead of scaling it, we want to set them to be whatever it is. And as I mentioned before, we need to do it based on our wall size. So we have our wall size here as an input. I'll drag out of here and search for make vector attribute. On the right output type, let's swap it to vector 3. So now we have a vector 3, and what we want to do is put the wall size into the X and the Y, because in our case, the width and the length are always the same. It is just squares in a grid. We don't have like a really long section compared to a really wide section. We're always squares. So that's why both X and Y are the same. So what we're going to do is take this wall size now and divide it by 2 by using a create attribute set to 2 in the detail panel. And then we need to offset the size of the points that it's actually using to merge with. The points are 100 by 100 by 100 by default, so we need to offset half of that to basically put it into the center. Because if we use it without the modifier, effectively it would become 50 units, either too big or too small. So from here, I'm going to grab ourselves a subtract node, and then using another create attribute, I'm going to set this to 50, which is half of the size of a default debugged point. I'm going to grab another make vector attribute. I'll grab this here, I'll duplicate it, and plug this output into it. And again, X and Y, just like we did up here. And this is where we're going to be subtracting. So now our get attribute from point index in our max and our min, we take our max and we want to add to it, and our subtract, we want to subtract from it. Again, because our original values are smaller, so we effectively want to increase the minimum and increase the maximum in the respective directions. So now we take this subtract node, plug this into in B for both of these, and then we plug these into the max and the min respectively. The max goes into the max and the min goes into min. At which point I can select this bounds modifier, press D to sample it, and you can see it is exactly the size of this hole. If I go ahead and scooch this over, it moves with it. So this is excellent. This gets us exactly the bounds we need. So now we have the bounds. We want to go ahead and scale the actual mesh from our data asset to fit these bounds. Now over here, we've been using the scale wall size for everything, and we can still continue to use this. So this PCG scale wall size takes our information, our data asset, our seed, and everything, and it goes ahead and actually just scales it as needed. So I'll go ahead and select this, grab our seed, copy this, and paste it right into this graph. Now the bounds modifier points will go into the points. The data asset is what we have brought in from here, from the input. So I'll drag it all the way through. Now the width and the depth we're calculating ourselves, so we don't plug those in, but our height, we can go ahead and grab from our wall height from here, drag it all the way through, and let's go ahead and just clean it up with a simple reroute. So now this is a little bit cleaner, and now we can plug in the width and the depth. And we don't want to just grab it from here because these are the bounds. We want the actual just full length of this. So now we can go ahead and just use these to calculate the actual length instead of the bounds. So what we do is from our max, we go ahead and subtract our minimum. Now this gets us the length, but just to make sure that it's always in the positive, I'm going to use an absolute, and that converts any negatives to positives. And then from here, I'm going to break vector attribute to get access to the individual axes. And then what we're going to do is plug X into the width and Y into the depth. And it's throwing us an error, and that's because the data asset isn't actually just the data asset, despite us calling it data asset here and here. What it actually wants is this get property from object path. It wants the specific thing in the data asset, not the entire data asset. So I'm going to drag out of here and search for get property from object path. And the property name is going to be our stairs, which is what we called it in the data asset. And then this is what actually gets plugged all the way through into our data asset, and now it is no longer complaining. So if I take this and take our output and plug it all the way through, then here we can already use our static mesh spawner. Now I'll grab a static mesh spawner from somewhere else and duplicate it down here. And the reason for that is because this one's already configured to be a selection by attribute with attribute name mesh as we need it for using this system. So I'll plug it all the way through. And if I take a look here, you can see it is now placed exactly in this hole. And if I make this hole bigger and reposition it, you can see it is now exactly the size of this. Now, one thing you're noticing is as I'm dragging this around, I'm getting a little bit extra and really don't want this. In order to fix this, it's quite simple. Over here where we're cutting out the floors and the ceilings, before we cut it out, I want to modify the extents. So I'm going to drag out of here and search for extents modifier. I'm going to plug this into the differences for both. So I'll detach the differences that were there originally, plug this into both. And then for the extents modifier, we're instead of set, we're going to change it to multiply. And what I want to do is set this to something like 0.75 for the X and the Y. And now you can see it is matching exactly. But if you have it just a little bit too far, you'll still get this problem. So you just want to make sure that when you're doing it, you have to be a little more accurate when you position it. But now we can go ahead and position it, scale it to whatever you want, make it bigger, and you can see it is cutting in everything out. But if you make it really tall, for example, right now, well, it is cutting out everything below, but you can see it is only spawning the one. And we want to spawn it on every single floor in the correct position and everything. So that's the next thing to do, is to make sure that when it is actually cutting out multiple floors, it is spawning on every single floor as we'd want. If you're enjoying the tutorial so far, I would love to hit the like button and subscribe for more awesome tutorials like this. Let's get back to it. Back here in our get selection bounds, we can just go ahead and continue it here, honestly. So I'll detach this output node. We need something else before that. And that something else is this copy points up simple. So I'll go ahead and copy it and we'll paste it right in here and plug this in. Now our wall height again is coming from our wall height here. So I'll just plug this all the way through just like so. But the number of loops is not the amount of floors that we have. So we actually need to calculate how many times we need to copy this up and then convert that number into that many points and split them. And unfortunately, there's no super simple way of doing that with just a simple node. So let me show you how to do that though, because there is a way in PCG. The first thing we're going to need to do is divide the actual height that we've calculated from our bounds and everything by our actual wall height. So I'll take our Z here and I'll divide it by our wall height, which we have right over here. So I'll just drag it all the way through into in B. And this is where I want the branch and to make use of the stairs mode. So I'll drag out of here, grab ourselves a branch and open up the branch. And this output to B is going to be based on the stairs mode. So I'll drag this all the way through and plug it in. So now depending on the stairs mode, it will do something different. And the thing we're going to change is this will not divide evenly into exactly what we want. So we need to either do a ceiling or a floor. So I'll grab a ceiling for output A and a floor to output B. Now ceiling means whatever your float decimal point is, it doesn't matter. Round it up to the nearest integer. And floor means round it down to the nearest integer. So this gets us the number of floors that we exactly need. Now from here, we need to get a way of generating effectively points. Now, one way I figured out to do that is using the create points grid node. By using it, we have the option to modify the extents and the cell size, and we can also put that, of course, in the detail panel. If I was to leave X on 500 and change Y to 50, then by my calculations, if I take 1000 using a create attribute with a value of 1000 and then divide it by the amount of floors, whether it's from the ceiling or the floor, we want to plug both of these routes in, then we can plug this into the cell size and get us what we want. In fact, if I press A here, and the bottom left corner, we select the actual loop here, we can see we have 2 points. And if you look here, we're going between 2 floors. If I move this up, it now only has 1. Okay, so now it is working. So now I can take this and do an attribute partition, and we want to partition it right here, set to index. Then your PCG copy points up simple will look like this with this attribute set. You might have noticed mine looked a little bit different. That's because I had it still modified for my testing, but yours will look like this, and there's no way of plugging in this point into the loops. It doesn't quite work. But all we're ever used this input for is to just loop on that number of things. We don't actually care about the input itself. So if you open up copy points up simple, for our input, we can change the loops here from attribute set to any. And when we change it to any, we can now plug our points right in here. And now it will do exactly the same thing as we had before, which is excellent. So now let's take this and output it all the way through, and let's see what we get. And just like so, we have our wall piece. This is good. If I move it down, well, seems like it's working, but something's going on. Basically, as you see, as I moved even further, it is copying the points, but it's not offset downwards in the correct amount. Because we're doing it based off the selection, we need to offset basically itself downwards, however much it needs to be in the right spot as well. So right before this output, let's get ourselves a transform points node, plug this all the way through to the output, and let's open it up. And we want the offset now here. So I'm going to make a vector attribute for offset min and offset max. For the vector, we want to select vector to have a 3 value one. And now what we want to do is back here when we have the Z, we want to take it and then divide it by a value. And that value, if I use create attribute, is -2. We're dividing it by half because it's already in the center. We only want it to go half the distance. And we're putting it as a negative so we don't have to multiply it by -1 afterwards to basically make it move down instead of up. And then we need to offset the original actual bounds of that point that it was used to create it. So we'll do an add with another create attribute, this time set to 50. And I'll go ahead and plug that in. And now this add is what goes into our Z, because that is where we need to modify it. And now if we take a look, you can see it is actually all the way through exactly where we want it. If I drop it a little bit lower, you can see it is now grabbing all of this and is coming up exactly where we want it to be up here. Now this is great for an elevator shaft, but again, right, we have this potentially being a stairs, and we wouldn't want stairs coming from up here all the way to the top floor, which is why in our blueprint, we have now stairs mode where we can just check this on, and it has removed the top layer. So excellent. So now we're getting it to be exactly where we want. And if I want to, I can go ahead and take it, copy it over here. Let's make it maybe a little bit more narrow, a little bit shorter, and I'll drop it, let's say over here. You just need to move it a bit down. And you can see once we line this up, we get this pretty much exactly where we want, where we have this section here all placed in. And again, if I want to, I can make this one longer, and now we have it right in here. Exactly the length and the depth that we would like. Now, as always, the project files are going to be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord is down below. Thank you again to the patrons. Let's get back to it. So this is great, but let me show you what happens when you swap out the stairs. The main thing between these two is the pivot point. The elevator shaft that I've created has the pivot point in the bottom center, while the stairs do not. So the stairs here have the pivot at the bottom side here, and these have it in the bottom center. So watch what happens when I select this and then replace our corner pillars here with it. When I plug this in, it will swap all the meshes, which is great. But now if I look here, it's off. The pivot isn't designed for this. Now at this point, okay, well, we created a system for this, right? We create a system to offset, and we've been using it. This offset transform. So let's go ahead and take it, and we'll duplicate it down here and plug this in before the static mesh spawner, and then plug this all the way through. And now I probably just need to offset these in X by half. Well, here's the thing. This is right now an absolute transform. I modify it by half, but it effectively hasn't moved. If I modify this by 100 in negative, then we're getting it to be slightly moving. But we don't want to guess on this value. It'd be much better if the offsets were also relative to the size of the mesh. Because when we scale things between our modules, the offset's going to need to be different. And if we want to always have it be offset by half, so that way it's procedural, then we need to make some changes. And we're going to make a slightly separate version for the elevator stairs compared to the one that's using everywhere else because of how we're creating it and how we're placing it. Let's start with the one for our walls and everything, the one we've been using this entire time. I'll go ahead and open up our PCG offset transforms. And here we're just plugging in our offsets and right directly in here. Instead of that, I want to do it based off the size of the mesh. Now, luckily for us, before this, we already set the bounds to be the size of the mesh. So what I'm going to do is get attribute from point index. I'm going to duplicate them up here. I'll plug our input into both of these. And in the top one, instead of offset, I want to select bounds max. And the bottom one, I want to select bounds min. Then just like we did before, I'm going to subtract bounds max from bounds min. I'll make it absolute. And then I found I need to multiply it by 2. We're doing a create attribute, setting that value to be 2. And now this is what we actually need to modify. And all we need to do is take our offset here and we need to multiply it by this value. So I'll go ahead and multiply it by this attribute. And the output of this multiply goes into offset min and offset max. So immediately you can see this one piece has disappeared. And if we go ahead and change it to negative 0.5, well, it has moved, but not quite accurately. You can see this one is not far enough. This one seems weird as well. They're not consistent. So for this method, we're going to make a slightly different version. But let's say you want to modify the walls here or something like that. If I change the interior wall here for the offset to be -1 in X, you can see it is now sticking out here by exactly 1 module. Everything has moved over by exactly 1 module, which is perfect. So now this offset is based off of the size of our modules. Now we're going to make a slightly different version for this, but that's okay. I'm going to navigate to this offset transforms. I'm going to duplicate it and I'm going to suffix it with stairs. And then with it still selected here in our main PCG building graph, I'll go ahead and just press this graph to replace it. So now we have the stairs version. And I'll open up the stairs here. So this is exactly what we had before, but we need to make slight modifications. And the main modification is actually here in this multiply by 2. We need to multiply it based on how much we've scaled the thing. Now we don't have this information. We've scaled it, but we've not retained this information. We do that here in the scale wall side. If I open it up and open up our scale mesh to size, over here, we're doing the scaling, but we're not saving how much we're scaling it by. So let's go ahead and do that. Let's save that attribute because we're going to need it afterwards. So I'm going to right click and search for add attribute. And you want the one under param. You don't want the math operation. And we plug this into this in, and the output of this goes into the transform points. And we want to save this output here, this make vector attribute. Now this is all good, but we need to specify what is it being saved to. Right now it's set to none, and this is what's going to be the variable name effectively that we're attaching to this attribute. So I'm going to call this scaled amount, and I'll copy this name. So if I select anything past this and just press A and select one of these points on the left here, doesn't matter which one, I can scroll all the way to the right and I have scaled amount X, Y, and Z, and now I have those values stored onto each point. So now in the stairs version, instead of this 2, we can replace it with that value. So I'll drag out, get another get attribute from point index. And then in the input source, I will paste in that scaled amount and plug that into our multiply. As soon as I do that, you can see we are now exactly where we want to be. Now, the only thing is, because we're doing it based on the bounds, these stairs don't go all the way to the top, and they're a bit high up because of the way the pivot is. But that's quite all right. In our data asset, we can now offset this just fine. So we can go ahead and offset in Z by -0.2, which is 20%. And then I want to scale it in Z by 1.9, so 90% taller in my case. And now if we take a look, it pretty much exactly lines up with the top stair here. And down below, it pretty much works as the first step. I can move it down a little bit more and scale it up a little bit higher if I'd like to. But you can see it is now lining up really well. And it does that for every single floor. And even though this one is longer and this one is narrower, you can see it all lines up. And just to show you what happens, if I turn off stairs mode in the blueprint, we get the stairs on this top level as well, like I mentioned before, going up to effectively the rooftop. And this is what we don't want, which is why we have a stairs mode versus an elevator mode. Now, like I mentioned, this is currently set up to use one or the other, but you can duplicate this setup and use a different data asset here by just taking this from inside to out here and plugging that in. And then you can create two different variations, one for stairs, one for elevators, and you'll just need to use different tags to specify which one is which. But what I want to do in the future tutorial is to specify that stuff, not on the original blueprint graph, but on the thing that is cutting it out. I want to put whether it's a stairs or an elevator onto that. That way we'll be able to have multiple stairs and multiple elevators all on the same system. But now, no matter where this is, we can go ahead and place this directly. Wherever we want, however wide we want, however narrow we want, and all is good. And one thing you might have noticed is the stairs are always facing the same way. There's no way of currently to rotate them to have them be a different direction. It is whatever the static mesh was originally. Now, what you'd want to do is add in a rotation here and add in the actual how much you want to rotate it and be good there. The problem with that is we're going to be doing the rotation afterwards, and we don't want to do the rotation afterwards. The rotation needs to happen before it calculates the scale and everything else. So that's going to be a slightly more complex setup, and unfortunately, this tutorial is already running long for today, so we'll go ahead and set this up next time. If you're craving more PCG content, check out this video right here to sate your craving of PCG.